Um, Up next, we have our final speaker today. So I'll be welcoming Rahul Athalye up to the stage in order to give us an update on the California prototype development project, which he's been working on for quite some time.
All right, good afternoon, everyone. Thanks for being here and thanks for having me. The California prototype development update, that's what the title of the presentation is, but this is really about we are calling it the CalBEM prototypes. And this project really has been with CalBEM for many years, since 2019, actually. And we are kind of coming to the end of that period now, finishing up with the last parts of the development of the first phase of this project. So wanted to give this update to the group to showcase all the work that has been done so far. I'm going to start by saying a big thanks to SCE for supporting this project for many years. Without that support, it just wouldn't have been possible. And I think this is pretty, one of the foundational pieces of work that everybody in this room can go on and continue to use in the future. So here's a brief agenda. I'm going to talk about the project background, the prototype's tag, and then I'll describe the progress to date by the building sector, and then also talk about all of the documentation, work products, where you can go access the prototypes, so on and so forth, and brief mention of the future work. So I'm going to start here with the objectives and the purpose of the project. This project started in 2019, as I mentioned, and at the beginning, we did a needs assessment on what the prototype's landscape looks like in California. And we came back with the fact that there were about 7 sets of prototypes that were floating around and were being used by not only policymaking agencies, but also by other stakeholders around the state. And so the main objective of this project was to develop this unified set of assumptions and prototypes that all policymaking agencies can use, so that we have the same framework and the same assumptions underlying all of the policymaking and decisions that are happening within the state. So that's kind of the overarching objective. The other thing we found when we did that needs assessment was that many of the assumptions and inputs did not have a basis, or there was at least not a lot of good documentation on where the assumptions came from. And so that was another important aspect of this project, which was to make sure that all the inputs that we are developing have stakeholder buy-in and that they are well documented. Another objective was to capture a majority of the California building stock. That included single-family, multifamily, and non-res. Rigorously document the inputs and assumptions, I just mentioned that. And also, another finding of the needs assessment was that the prototype models were not easily accessible. Sometimes they were behind a wrapper, or sometimes people just didn't know where to go to find prototype models for California. And so another objective of this project was to host these files at a central location to make them easily accessible. OK, so here is the project team and also the technical advisory group. The project team starts with NORESCO. I'm from NORESCO. We did most of the technical development of the prototypes. Energy Solutions did the project management. So they organized the tag, they organized the meetings. They kept us going throughout the project, making sure we are hitting our milestones. And provided a ton of input and feedback. So, and then SCE, of course, was the main funding agency. I'll mention Ryan, who's been here from the beginning from SCE, and also Andres, who also provided oversight and a lot of review and feedback on all the documentation that came out of the project. Lastly, the CalBEM was the tag host. So throughout these meetings over the past few years, we've been using this venue to collect more and more feedback on the project. Then the technical advisory group. So the purpose of that was to kind of bring together the key stakeholders as well as industry experts with respect to energy modeling and prototype development. so that we have a place where we can take our work and our progress and share that with the group, and also collect feedback so that we can improve the modeling and the assumptions. So Energy Commission and CPUC were the two lead agencies. The IOUs were part of the tag. CalTF and folks from CalTF were reviewers, as well as folks from PNNL, NREL, and other stakeholders were part of this tag over the years. We've had about 15 meetings over the past 3 or 4 years of this tag to collect input. So this is kind of the framework of the project, the team and the technical advisory group guiding the development. Next, I'm going to talk about the approach to the prototype development. So it's really that was done in 4 main steps. First, we start with the building stock assessment. So one of the main objectives was to represent the California building stock. And so as part of that, we looked at the building stock and tried to capture the main features in the building stock, such as the size of the buildings, the number of stories, and where for example, for the office prototypes, where the distinction should be made between a small office and a medium office and a large office. Those are the kinds of questions that the building stock answered. This is a very important step because this step helps us understand which prototypes we want to build, and then all of the other steps follow from that. So once we know which prototypes we want to build, the next step is to start collecting inputs for those prototypes. So here we looked at a bunch of data sources. 2 of the main ones were RAS and SUS. RAS and SUS are both done by the CEC, and they collect information on California buildings. So those were rich sources of data for the second phase. And then after we have all of the inputs, we construct the models, and then we validate the models. So those were the next 2 steps. So next I'm going to talk about the 3 building sectors and the progress that has been made to date on those prototypes. So first up is the single family sector. So as you can see, there are 4 prototypes that we came up with, and this was heavily driven by the building stock analysis. You may not know or you may not imagine this, but a large portion of the building stock, single family building stock in California, is pre-1970, and it is smaller than 1,500 square foot. You think of the Bay Area and the LA area, and a lot of those single family homes are pretty small, and our existing prototypes are over 22,000 square feet. So those would not be a good representation of that building stock, because in a single family home, there's only one kitchen, right? Whether it's a 1,200 square foot home or a 2,500 square foot home, there's only one kitchen, and not all of the loads are scaling with square footage. So it's really important to get this part right, the first part, because everything else will be based on that, and having this representation of the stock is really important. So yeah, this table shows the 4 prototypes, the number of stories and the number of bedrooms, and the foundation type as well. All of that is based on data that we got from RAS. We also looked at vintage bins. So we've gone with 4 existing vintage bins and 1 new construction vintage bin. Again, this was based on a lot of data from RAS and other sources. We looked at when construction happened within the state. So there were these periods of economic boom and bust. So that was one criteria. Another one was, when did the codes experience a significant amount of change? And then a third criteria was technological breaks. So these would be things like going from a single pane window to a double pane window. That happened around the 2005, 2006 period. So those were the kinds of factors that were considered when we decided the vintage binning. So you can actually go more granular than this, but there's also the aspect of being too granular and having too many models, because when you're doing policymaking analyses, you don't want to have too many models, because then you have another problem. You have created another problem, which is to manage all of the data that comes out of it, do the QC, manage the data, so on and so forth. So we've created this as like an intermediate between being too simple and too complex. And there's basis behind that, and that's documented. So, okay. So here are the different phases. All of these are now complete: the stock assessment, the input collection, building of the models, and the validation. All of that is complete. The models have been published, and the documentation is available as well. So you can go access the models, and I'll show where that's located. Next up are the low-rise multifamily prototypes. So these two came from TRC, a study that TRC did. Again, it was funded by SCE. And that study also looked at the building stock and various data sources. And they based the prototypes based on the distribution of number of bedrooms, the floor area of different studio apartment versus a 2-bedroom apartment, so on and so forth. So matching that distribution in the stock with what's in the prototype. So when we looked at these prototypes, which by the way, I should say, for every sector, we also looked at all of the existing prototypes, so the DOE prototypes, the CEC prototypes, and the CPUC prototypes. And in this case, it turned out that the CEC prototypes were a very good match with the building stock. So we didn't have to do any development work. We just went with with what was already there. So so the LRMF prototypes worked really well. The vintage bins are the same as single family. And then again, all of the steps have been completed, and the models are available. Both the single family and low-rise multifamily prototypes were based on RAS data primarily. There were other data sources used as well. But then coming to non-res and the high-rise multifamily prototypes, here we shifted to SUS. So SUS data was compiled. I think the survey was done in 2022. And data started coming out from the SUS team around late 2024. So we are just about a year away from that. So once we started to get that data, we dived into it, and we tried to collect as many inputs as we could. And then there were other data sources like CBEX, the assumptions that came out of the PNNL models, and all of the work that PNNL has done, as well as the CEC, ACM, and data from other sources in California. So this list of prototypes, again, was vetted with the tag. Again, we looked at what the CEC had, what the CPUC had, what DOE had, and what the stock requires for a good representation. And so this is the outcome of that study. So these are the prototypes that provide a good balance between what's out there and what's in the stock. There are some really cool things in here. I mean, it's, I don't have time to delve into the details, but I'll just mention one, which is the 3 office prototypes. So the office prototypes have been long criticized for having too simple of a zoning layout. There's just the 5 perimeter zones and 1 core zone. So one thing we've done here is we've tried to go a little bit more detailed than that and add more detail to the spaces. And this way, we are able to capture some of the measures with respect to VAV turn down, ventilation turn down, so on and so forth. So there are a number of other enhancements like that throughout the prototypes, throughout the non-res prototypes. So there'll be documentation that comes out, and that should have all of those details. So the building stock assessment and the input collection is done. And we are at the tail end of constructing and validating the models, and also creating the documentation. The schedule right now for this is to be done with all of this by the end of December. So you should be able to access this in January. Okay, one of the other cool things that came out of this, this project is this thing we are calling the scorecard database. So we have these Excel-based prototype descriptions for every prototype. So we have these for single family, multifamily, as well as each of the non-res prototypes. There is a lot, we need these. First of all, we need these to be human readable. There's been a lot of talk about machine readable, and I'm going to be talking about that in a second. But we need these to have discussions amongst ourselves, to debate what the value should be, to debate what the assumptions should be. But this does not lend itself very well to automation and to generating models from here. So there was a neat idea from one of my colleagues, Naseem, and also Rob, who's here. What we did was we took all of the inputs in these scorecards, and we created an automated way to put that in a scorecard database. So all of the information in the scorecard now automatically gets put into the scorecard database. This can be exported as a CSV or any of the other machine-readable formats. And another engine or another wrapper software can easily read that and create prototypes from there. So this goes back to when we first began development of the prototypes. There was a comment that all of this stuff that we are doing, all of these assumptions that we are creating and the scorecards that we are building are not of much use because they're in Excel format, and it really has to be in a machine-readable format. That comment was like about 3-4 years ago, and now we've come a full circle, and we're able to generate that. So this is really cool, and I think this is really going to help automate the process of going from input in the scorecard all the way to a model. This is automated right now. The output is in Energy Plus format. I'm looking at you, Liam. but it is engine agnostic, so you could take this data. There are some fixed inputs like geometry, and there has to be a way to generate the HVAC system for your engine, but at least all of this data is available in a format that's machine readable. So. It's not there yet. But, yeah. Not the geometry isn't, but let's talk about that later. Yeah. Okay. Okay. Quickly, 5 minutes. Okay, thanks. Yeah, data sources used. RAS and SUSE were the main ones. Dodge construction data, big thanks to CEC for sharing that with us, because that helped us with the non-res commercial stock distribution analysis. And then there were all of these other ones that we used for a variety of inputs and cross-checking and cross-validation. So I won't spend too much time on that. So the applications. So now we are at the point where we have the prototypes and we have the assumptions. We can start to harmonize the assumptions across agencies, across CEC, across CPUC. CalBEM has been interested in this work also. So we're at a place where we can actually start having the same underlying assumptions for all of the policymaking analysis that uses prototypes. Then there are some other applications as well, like software testing by vendors is a possibility. And the files are hosted online, so other stakeholders, consultants, analysts, universities can use the prototypes to run all kinds of California-specific analysis. And then, yeah, another cool thing was the scorecard database. So again, this is an automated method for developing prototypes from input. So hopefully this is going to be hugely valuable to the group here. We have a new, well, it's not new anymore, but there is a new web page. It's on the CalBEM website, so you can click that link and it'll take you to a GitHub repository where all the models are. We're trying to keep track of all of the changes that happen to the models as well. The project output, I won't spend too much time on the details here, but what I'll say is that there has been a tremendous amount of output in terms of documentation from this project. So all of this is hosted a lot of this is hosted on the 2050 CalBEM SharePoint and should be accessible to you. Some of the other memos and reports are also accessible from the GitHub website. And there's some more coming as well. We have published about 3 papers so far, and there are a couple more in the works for the next Symbuild conference. So again, there's some documentation of the work. Future work, yeah, just finish the non-residential prototype development, support the CEC and CPUC in enhancing prototype assumptions and harmonizing where possible. There has been a request to provide batch processing capability because it's hard to interact with 2,000 models at a time. So we are looking into that and thinking about what's the best way to go about doing that. The tag is also a really key aspect of this project, and helping improve and maintain the prototypes through the future with the tag. I think that's a really great outcome. So, okay. Yeah, I just wanted to touch on the project team real quick. big thanks to Ryan and Andres for always being there, throughout the project, also for funding the project and providing guidance. I'll touch on the energy solutions team first. Brian here has been with the project right from the beginning, helping us develop the framework, hosting meetings, keeping us on track, and same with Jacob. And then Krishnan joined the team recently and really helped us get to the finish line. So big thanks to Energy Solutions as well. And then the NORESCO team, I just wanted to tell you a little bit about who did what. So Demian, who's in the room here, he's been helping us review all the models and make sure they're up to snuff. Naseem came up with the idea for the scorecard database, and she's helping put all of the non-res models together. Fatime did a lot of the work on the SUS, on extracting information from SUS and putting it together for the non-res prototypes. And Mohammed and Ben did the similar exercise for RAS data for single family and low-rise multifamily. And then, I'm here just doing all the talking. And that photo is actually pretty old, so I just took the liberty of updating it for the current look. So thanks for listening, everyone, and happy to have questions. Thanks, Sheila.
Rahul, 3 quick questions. The medium office building you showed, is there going to be an open comment period for that we can make comments about it, or has that ship sailed?
No. So the scorecards, I don't know if Krishnan is in here. Yeah. So we are putting the scorecards on the SharePoint or the GitHub, and then there'll be time to provide comments on that.
On what the...
On the zoning layout and yeah.
Oh, excellent. Okay, great. Yeah, it'd be nice to see what it looks like vertically as well.
Yeah, with the multipliers. Yeah, we talked.
Not multipliers, just, is there a 4-foot ceiling plenum like
I
the old
see.
ridiculous one?
Okay.
I hope you got rid of that.
It's still there, I think.
It's still there, okay. Okay, you'll recall last year my #1 request about this was please make sure there's GBXML files available for all. So is there?
So we did that, I think, for the small office, yeah.
We haven't posted for everything, but there is a workflow already there. As soon as modified, that would be done.
Awesome, thanks. And then last one, do any of the new prototypes include any thermal bridging?
No, they don't.
Okay.
Yeah.
Thanks.
How well are they going to compare against real buildings?
That's a good question, Greg. So we are using SUS data for the validation. RAS, so for the single family and low-rise multifamily, we used RAS to do the validation. So those should match RAS on a weighted basis. So we have all of these vintages and a number of prototypes for every climate zone. So when you aggregate that up to the climate zone level, it should match what's in RAS. And then we are doing the same thing for SUS, although SUS is somewhat limited because there's only 12 building types that are collected, or rather the survey kind of aggregates information into 12 building types. And so we are a little bit limited. The substitute we've been thinking about is Energy Star Portfolio Manager right now.
Okay, yeah, I guess my point is more about having a prototype model that represents an aggregate of building types or an average building. Real buildings tend to land pretty far away from that. And so I guess the word of caution to the group here is like when using these to inform codes and standards decisions, don't necessarily assume that, oh, it's an office building, the prototype reaction to this measure is X, so it'll be the same for all office buildings.
Yeah, I mean, that's a fair comment. I think the current assumptions are what they are. You could say that about the current prototypes also. There are some inherent limitations in this approach to the analysis, but we don't have any other tools. I mean, the other option is make a model for every building, but then that leads to a tremendous amount of data and more QC and so on. So this is kind of the best available approach we have right now. So
yeah, so maybe future work is trying to collect real buildings, for these building types, and then in building types that don't have a prototype model and do some validation, do some comparison to understand how well they represent real buildings or don't. Not saying that this isn't useful, I'm just
Yeah,
grain of salt here.
yeah.
Yeah, thanks.
There we go, now it's on. Turned off. Building on what Liam asked about thermal bridging and what Greg said about accuracy, I know you're working towards accurate enough, not too complicated, not too many models, you already have over 2,000. How are you going to consider documenting the exterior surface area to floor ratio for every building to like give an indication of the importance of thermal bridging per prototype, in the scorecard at least?
Yeah, that, I think I'm trying to think if the dimensions are in the prototypes. I don't believe they are. The floor area of every zone is in, it's the floor area, the volume, the window to wall ratio, all of that information is there. But yeah, the exterior surface area information is not in there right now. But that's a good point. I mean, that could be added.
Because for the small single family buildings, you'll find that it's super high and super important, and then thermal bridging is actually a big contributor where you could lose 20 to 30% extra heat in a tiny envelope versus a huge office surface area ratio much closer to 1.
Okay.
And less important to even account for thermal bridging.
Well, submit a comment.
Okay.
Yeah, we'd appreciate that. Go ahead.
Hi, Rahul. So first of all, great work here. You showed 4 prototypes for the single family, and I thought that's great because you can never really create one prototype that represents a building class, right?
Mm-hmm.
So having 4 was really good to see because then you can assign weights to those 4.
Correct.
That way you're like, okay, we're capturing some of the outliers on this side and that side, and then there's a median that you can assign a weight to. Are you planning on doing multiple prototypes for commercial buildings as well, or is it going to be one prototype for each?
It's one prototype. I mean, for office, we have 3, for example, but otherwise there is just one prototype. And one of the requests we actually got was to collapse the vintages into one existing vintage and one new construction. So there's thinking out there to go even simpler.
No, I would really encourage that. I know I'm increasing work here, but when you end up using these prototypes, and we've used these for ASHRAE work, in fact, projects we did together a while back. The problem is always whatever you have in that prototype is reality, and the outliers are never quite seen. So I would really encourage thinking in terms of multiple prototypes for every single type. Mm-hmm. I know that's more work, that's more things you have to manage, but it would really improve the quality of output that comes in.
Thanks, Mudit. Yep, that's a good point.
Hi, this is Jared from E3. So I have sort of a 2-part question. So I saw it listed on the screen when in all the inputs that went into the work. You listed ResDoc and ComStock. Mm-hmm. So I guess my one question is how does this work sort of correspond with what is in ResDoc and ComStock? Like, is it for those who don't know, ResDoc and ComStock is supposed to represent the entire building stock across the country using thousands of energy simulations. And so like we use that all the time when we're trying to model existing buildings. So I'm very curious as how this will compare to that. And then maybe a more naive question is, when would we use this new data set to model existing buildings instead of ResDoc and ComStock?
That's a good question. I don't have a ton of interaction with ResDoc and ComStock, but what I can say is that those models are at a lot more granular level. However, interacting with that also is equally more difficult. So with these models, while they are, I would say, they don't quite have the same distributions that that NREL came up with. So in that aspect, they are simpler. But I think these are more easily manipulated and more easily used to do the kind of work that we have to do on a day-to-day basis.
Yeah, I just say that because sort of to build off of Greg's comment, like as you said, you're never going to see sort of the edge cases when we look at prototypes, whereas something like ResDoc and ComStock is, because it has such a vast distribution of building types, of all the different inputs, you get to sort of see that curve. So yeah, I absolutely recognize this, obviously much simpler and has makes a lot of sense for like codes and standards work. But yeah, also a plug for ResTalk and Comstock when it.
And also all of the AI stuff that we've been talking about, maybe in the future it might be possible to go more granular with some of these and, incorporate more distributions for the various parameters. So it's out there. I mean, that solution is out there.
I just have a quick question. One of the slides you show like more realistic HVAC zoning pattern. I know that for the other current prototype, they all have a box model, right? But my question is, because you have a more completed HVAC zoning pattern, then most likely you'll have more embedded hour. That's a metal hour issue, right? The heating temperature higher than the set point, and cooling temperature, higher, something like that. I just wonder, what's your internal criteria, like how many cooling embedded hour, how many heating embedded hour for the prototype, because you have a more completed zoning pattern.
Yeah, thanks. I think that's a great point as well. It's going to be the standard 300. Like we wouldn't accept anything beyond that, but that would only be for the control zone. So one of the things that came out of SUS was actually there are a lot of CAV systems serving those kinds of zoning layouts. So what we are looking at here on the screen, there's a lot of CAV systems out there in the building stock that are serving this kind of layout. They have one control zone, and then all the other zones just get what they get. So in that case, there are going to be unmet hours, but the control zone should not have any unmet hours. Yeah.
Do we have time for one more, or are we done?
It's a quick one.
Oh.
Are there any ADU prototypes planned?
Yes, I don't know if Aliyah is in the room, but yeah, at one point, I think Aliyah was working on those, and we kind of said they are already at it, let them figure out what the stock looks like, what the prototype looks like, and then we'll just merge it into this process. So. Oh, go ahead.
Look at the website. That model's not up there, and the models that are up there are just scorecards. So it's impossible to review or comment. So my request is, will you be putting out the models are up there, open comment period, comments welcome.
Yes, yes, yep. We'll do that, Krishnan. Yeah.
Yeah, that should happen in January.
Yeah.
Thank you.
Right, thanks everyone. Be at BEM Bingo.